Okay, so get this right. You're relaxing, sipping some green tea, and meanwhile, it's like a microscopic battle is going on inside your body.
It really is remarkable. We're talking about the potential for green tea to combat pesticide exposure. The research you sent is fascinating.
It sounds like something straight out of a sci-fi movie.
Yeah.
So where do we even begin? We're talking about green tea, but more specifically.
It all comes down to EGCG. It's a powerful antioxidant found in green tea, and researchers believe it could protect us from the effects of organophosphate pesticides.
Right, organophosphates. Those are those nasty chemicals they use in agriculture. OPs, as I've seen them shortened to.
Exactly, OPs.
Oh,
And they're everywhere, which means exposure is a real concern. It's not just farm workers either. Anyone who eats food treated with these pesticides could be at risk.
that's a bit worrying, honestly. But what makes these OPs so bad for us? How do they mess with our systems?
Well, they disrupt a vital enzyme called acetylcholinesterase, ACE for short. It's crucial for our nerve function, like a messenger ensuring our nerve cells can communicate.
Okay, so our internal communication system, basically.
Yeah.
And OPs mess that up.
They do. When ACE is inhibited, which is what these OPs do, it can lead to a whole host of problems. Neurological issues, muscle weakness, even long-term risks like Alzheimer's.
That's pretty scary stuff. So that's where EGCG, our green tea hero, steps in, like swooping in to save the day.
That's the idea. Researchers wanted to see if EGCG could offer protection against these harmful effects. They designed a study using zebrafish, exposing them to 3 common OPs, chlorpyrifos, dichlorobos, and malathion, and then they administered EGCG.
Zebrafish. I've heard of using them in research. They're like the go-to, right?
You could say that. They share a surprising amount of genetic similarity with humans, especially when it comes to genes involved in the nervous system.
Ah, so what we learned from them could be applicable to us.
And they're transparent, right?
Yeah, exactly. Their embryos are transparent, which is incredible for research because we can actually observe what's happening at a cellular level in real time.
So they exposed the zebrafish to these OPs. What happened? Was EGCG able to counteract the effects?
The results were pretty amazing, actually. EGCG significantly reversed the HEE inhibition caused by the pesticides. In some cases, enzyme activity in the zebrafish brains and spines increased by over 50%. It was remarkable.
Wow, over 50%. That's a huge improvement. But how is EGCG doing this? What's going on at the molecular level? Well, the research suggests that EGCG is basically in a race with the OPs. They're both vying for binding sites on the ACE enzyme, and it seems like EGCG is faster.
So it's like EGCG is taking up all the parking spots before the OPs can get there, and that's how it protects the enzyme.
Exactly. But the researchers took it a step further. They used something called molecular docking simulations. It's a way to visualize how molecules interact, almost like watching a microscopic ballet.
Okay, I kind of get it. So they're watching EGCG and these pesticides interacting with the ACE molecule in real time.
Right. And they found that EGCG binds to the ACE through very specific forces, things like hydrogen bonds and steric hindrance. These forces help it secure its position and essentially create a protective barrier around the enzyme.
That's incredible. So it's not just a theory. They actually witnessed this interaction taking place and confirming that EDCG is blocking those pesticides from doing their damage. It's amazing to think this is all happening within our bodies when we drink green tea.
It's pretty mind-blowing, and it really underscores the potential here for mitigating the harmful effects of pesticide exposure, something that affects a significant portion of the population.
This is why I love these deep dives. You start with green tea, and suddenly we're talking about molecular battles and microscopic ballets. It's incredible.
It really shows you the power of nature and how much more we have to learn.
Exactly. Speaking of which, this is just one aspect of EGCG, right? We also have this whole other paper on angiogenesis. I'll be honest, I had to brush up on that one a bit.
It's a bit of a mouthful, isn't it? Angiogenesis. But it's actually a pretty simple concept. Think of it like this. It's your body's way of building new roads, but instead of asphalt, it uses blood vessels.
Okay, so new blood vessels, those are essential, right? Like we need those roads to deliver nutrients and oxygen to our cells.
Exactly. And it's crucial for so many things. Wound healing, development, all sorts of important processes. But here's the thing.
What is that?
Sometimes you have too much of a good thing. Too much angiogenesis can actually be a bad thing.
So it's like you don't always need more roads. Sometimes you need to regulate the traffic a bit.
Precisely. And that's where EGCG comes in. Research suggests that it has anti-angiogenic properties. It can actually influence where and when these new blood vessels are formed.
Kind of like a city planner for our blood vessels, making sure everything is in the right place.
A very good analogy. And there are certain conditions where this regulation is really important. Cancer, for example.
Right, because tumors need a blood supply to grow. They need those roads to bring them the fuel they need.
You got it. So by inhibiting angiogenesis, EGCG could potentially cut off the tumor's supply lines, essentially starving it.
Amazing. So not only can it protect us from pesticides, but it might also hold the key to fighting cancer. EGCG is on a roll here.
And it doesn't stop there. The research also mentioned endometriosis.
Now, that's a condition that causes a lot of pain, right? It's when tissue, similar to the lining of the uterus, starts growing outside of it.
That's right. And sadly, the current treatment options aren't always effective, and they often come with unwanted side effects.
So where does EGCG fit into all of this? How could it help with endometriosis?
Well, one of the things that happens with endometriosis is that new blood vessels form to supply these endometrial growths. And as we were just discussing, EGCG has the potential to influence angiogenesis.
So it could potentially reduce the growth of those lesions by limiting their blood supply.
Exactly.
Yeah.
It's still early days, of course. More research is needed, but the possibilities are definitely exciting. Just imagine something as simple as a cup of tea having such a profound impact on our health.
It really makes you think twice about what's in your cupboard, doesn't it? We often turn to pharmaceuticals for solutions, but sometimes the answer is right there in nature.
I completely agree. And who knows what other amazing properties of EGCG we might uncover in the future.
It really makes you appreciate the power of simple things, doesn't it? Like, we just had this whole conversation about molecular interactions, and here we are talking about a cup of tea.
It's amazing, isn't it? And what's even more remarkable is that we've only just scratched the surface. Every discovery opens up a whole new world of possibilities.
So for someone listening right now, maybe even enjoying a cup of green tea as we speak, what's the key takeaway from this deep dive?
I think the main thing to remember is that EGCG, this compound in green tea, it's showing incredible potential. We're talking about protecting our bodies from pesticides, maybe even influencing diseases like cancer and endometriosis. It's really exciting stuff.
I mean, it almost makes you want to raise your mug in a toast, right, to EGCG. But, like you've been saying, it's still early days.
Absolutely. More research is needed. We need to confirm these findings, figure out the right dosages, and explore all the potential applications of EGCG. There's still so much to learn.
That being said, I don't think it hurts to add a little more green tea to our lives. I mean, it's delicious, easy to find, and clearly it has a lot to offer.
I completely agree. And it makes you think, why do we always reach for pills and potions? Nature might have the answers we've been looking for all along.
Like they say, let food be thy medicine. And when that food is as enjoyable as green tea, even better, right? Well, this has been fascinating. Thanks for taking the time to break it all down for us.
My pleasure. These kinds of conversations, exploring the latest discoveries, it's always a pleasure. And when it's about something as fascinating as EGCG, even more so.